In question number 16, it says that which one of the following combination is incorrect. So again, we have to search for incorrect option. So option number 1 says swing of cricket ball and Magnus effect. Yes, the cricket ball swings due to the Magnus effect. So this is a true statement. Venturi meter, Bernoulli's theorem. Yes, Venturi meter works on the Bernoulli's principle. So this is also true. Hydraulic lift, Archimedes principle. No, this is wrong because hydraulic lift works on the Pascal's law. So this is our false option. And fourth option says blood flow and heart attack, Bernoulli's theorem. Yes, we know that the blood flows due to the Bernoulli's theorem. So this is also true. So according to this, we can say that our option 3 will be the correct choice because we need to find the incorrect option. So our third is the correct option. Let's move to the question number 17. In question number 17, it says that two immiscible liquid of densities rho and 3 rho are put in a container. The height of each liquid is h. A solid cylinder of length L and density D is put in this container. The cylinder floats completely inside liquids with its axis vertical and a length L by 3 in the denser liquid. The density D is equal to. So according to the question, if there is a container, in this container there is a two immiscible liquids of density rho and 3 rho, and we know that the higher density will always at the lower level. So we can say that the lighter liquid will be above and the denser liquid will be below. That means 3 rho will be below and rho will be above. And according to the question, height of each liquid is h. So if this height is h and this height is also h. A solid cylinder of length L and density D is put in this container. So a solid cylinder of length L and density D is floating completely inside liquids with L by 3 in the denser liquid. That means we have a cylinder. That cylinder floats such that its L by 3 height is in denser liquid. So we can say that the 2L by 3 will be in lighter liquid or rarer liquid because total length is L. And the density of this cylinder is D. Let's say if A is the cross-sectional area of the cylinder, so we can write the net force acting on the cylinder will be 0 because it is floating. So what are the forces acting on the cylinder? First is the mg, right? Second, the buoyancy force due to the upper liquid. Let's say this is buoyancy force due to liquid 1. And third, the buoyancy force due to the lower liquid. So this is the buoyancy force due to the liquid 2. So for equilibrium, the buoyancy force of 1 plus buoyancy force of 2 must be equal to the weight of the cylinder. So now what will be the buoyancy force due to 1? We know that the buoyancy force will be equal to the volume immersed inside the liquid into density of the liquid into G. So buoyancy force due to 1 is the buoyancy force due to upper liquid. So what is the volume inside the upper liquid? So we can write 2L by 3 into A. This is the volume inside the upper liquid. What is the density of the liquid? Rho into G plus buoyancy force due to the lower liquid. What is the buoyancy force due to the lower liquid? So the volume inside, that will be L by 3A into density of the liquid, that is 3 rho into G. This is the buoyancy force due to lower liquid. And what will be the total weight? So total weight will be total volume into density of the cylinder into G. So total volume is area into total length, that will be AL, and density is D into G. According to the question, density is D, right? So as you can see that AL will cancel out, G will cancel out. So we will get 2 rho by 3 plus 3 will cancel out. Rho will be equal to D. So we can say that the density of the cylinder will be equal to 5 rho by 3. So we can say that our option number 1 will be the correct choice. Now let's move to the question number 18. In question number 18, it says that surface tension of soap solution is 4 into 10⁻² Newton per meter. If a soap bubble of radius 5 cm is blown, then the amount of work done. We know that when you blow a soap bubble or water drop, the work done will be equal to the change in surface energy of the water drop or bubble. And what is the surface energy? Surface energy is defined as the surface tension into change in area. This is our work done. But since it is a bubble, so bubble will have two surface area. One is inside and other is outside. So we will multiply it with 2 also. So this is our total work done. So what is the surface tension? So surface tension is 4 into 10 to the power minus 2. And what is area? Since there was initially no bubble, now there is a bubble of radius 5 centimeters. So we can say that the initial area is 0 and the final area will be equal to 4 pi into radius square. Since 5 centimeter radius is given, so we should convert it with the SI unit, square into 2, because there is 2 surface area. So by solving we will get 800 pi into 10 to the power minus 6 joule. So we can also write it 8 pi into 10 to the power minus 4 joule. So we can say that our option number 1 will be the correct choice. Now let's move to the question number 19. In question number 19, it says that the increasing order of normal reaction applied by the base of vessel on the liquid R. We know that the normal reaction applied by the base in every container will be equal to the force applied by the liquid at the base. And since the height of each column is same, so we can say that the pressure at the bottom of each container will be same, and that will be equal to P naught plus rho G H, because height is same, so the pressure will remain same. So we can say that force will be equal to pressure into area. So force at A will be equal to pressure at A into area at A. Force on B will be equal to pressure on B into area of B. And force on C will be equal to pressure in C into area of C. And this force will also be equal to the normal reaction. Why? Because there will be action and reaction, right? If the liquid applies force F on the base of the container, then the base of the container will apply equal and opposite force, normal reaction, on the liquid. So they will be equal. So since area of A is less than area of B is less than area of C, so from here we can say that since area of A is less, so normal reaction on A will be less than B less than C. So we can say that our option number 1 will be the correct choice. Let's move to the question number 20. In question number 20, it says that a cubical block of iron of side 13.6 centimeter is floating in mercury in a vessel. Water is poured in the vessel until it just covers the iron block. What is the height of water column? So again, this is a two immiscible liquid, water and mercury. So according to the question, there is a container, and in this container there is already a mercury at the bottom. And cubical block of iron of side 13.6 centimeters floating in a mercury. Now water is poured the vessel until it just covers the iron block. That means if this is our iron block, so water is filled up to this height such that it covers complete iron block. So we need to find the what is the height of water column. That means we have to find this height h. And let's say if A is the side of cube, then A is equal to 13.6 centimeter. It is given in the question. So the base area of the cube will be equal to A square. And if this height is h, so we can write this height will be equal to A minus h. If A is the our what? A is equal to 13.6 centimeter. It is given in the question. A is the side length of the cube. So we can write it like this. So this height is A minus h and this is h. So again, since it is floating, so the net force on the cube must be 0. So what are the forces acting? One is simply its weight mg. Other, the buoyancy force due to the water. And the buoyancy force due to the mercury. Right? So for the equilibrium, we can say that the net force should be what? 0. So according to this, we can say that the buoyancy force due to water plus buoyancy force due to mercury must be equal to the weight of the cube. So if I put the values here, we know that the buoyancy force is volume immersed into density of the liquid into G. So what is the volume immersed in water? That will be equal to A square into H, area into height. This is our volume immersed inside the water. And we know that the density of the water is how much? It is given in the question, that is 1 gram. So into 1, and G is acceleration due to gravity. This is our buoyancy force due to water. Similarly, we can write the buoyancy force due to the mercury. That will be equal to volume immersed inside the mercury, and that will be equal to area into height, that is A minus H, into density of the mercury, and that is equal to 13.6. It is given in the question, right? Into G. This is the buoyancy force due to mercury, and that will be equal to mg. M is the mass of the cube. So what will be the mass of the cube? We know that total volume of the cube, that is A cube, into density of the cube. Density of the cube is 7.2. So 7.2 into G. So from here we can see that G will cancel out. A square and cube will cancel out. So you will get H plus A minus H into 13.6 will be equal to A into 7.2. So if I rearrange it, we will get H will be equal to 13.6 minus 7.2 into A divided by 13.6 minus 1. By solving this, we will get 6.4 divided by 12.6. And what is the value of A? Value of A is 13.6. So if I put the value of A here, so by solving you will get 6.9 centimeter. So we can say that our option number 1 will be the correct choice. Let's move to the question number 21.